next couple of days, we're going to be talking about tropical cyclones. Normally, you guys probably think of tropical cyclones under their kind of Americanized name of hurricanes. Uh, but hurricanes is a more specific name for tropical cyclones that are in the Atlantic Ocean. Other places call them typhoons, other places call them cyclones. So tropical cyclones is the generic name for these big storms. This first picture here shows Hurricane Fran. Hurricane Fran hit a long time ago, it was 1996, and you can see a couple things from just looking at this picture, which is why I like to start with this picture, this satellite image. First of all, you see the roundness of it, very round with a very clear circular eye. That means it's a pretty strong storm. You see that it's counterclockwise. Okay, the counterclockwise spin means it's in the northern hemisphere. Okay, also easy to tell because here's Florida and here's Cuba. Okay, and we'll be talking about things like rotation, the parts, when we get to the notes here. The notes for the tropical cyclones are different. Okay, you've probably seen from your note sheet. Make sure you really pay attention as I talk, and you'll be able to figure it out because the information really is not too difficult. Okay, we're starting at the beginning with where tropical storms form. They form kind of as you expect in tropical ocean water. Okay, so hurricanes, cyclones, typhoons, they form in tropical ocean water. You can see the ones that hit us, the hurricanes, are forming usually off the coast of Africa or in the Caribbean. Okay, the ones that hit Hawaii form off the coast of Mexico. The typhoons that get Australia are forming the South Pacific, the typhoons for China, Japan, the Pacific here, and the cyclones form the Indian Ocean here. Okay. Why are they forming in tropical ocean water? Because the energy for tropical cyclones comes from evaporation of water. Water is going to evaporate with warmer temperatures. So if the surface of the ocean gets around 80 to 85 degrees Fahrenheit, the water is going to evaporate into the air, it's going to cause it to rise, and we're going to start to form a tropical cyclone. Okay, so that's kind of be our stages for forming them. So the first stage in the formation of a hurricane or tropical cyclone. A large area of the ocean is heated by the sun. Okay? And if you need, you probably need to pause the video to write down these steps. So first step, large area of ocean is heated by the sun. Second step, the warm water heats the air above it and evaporates some water into it. That warm air rises, making low pressure and rain, the clouds that we see as the hurricane. The Coriolis effect then causes the air to spiral in that rushes in to replace the rising air. Okay, and we're going to go over what Coriolis effect means here on the next page. So basically, the sun heats the water heats the air above it and evaporates water into it, hot air rises, the air that rushes in to replace that rising air spirals because of the Coriolis effect, and it intensifies to form a tropical cyclone, okay, a hurricane. Okay, so this spiraling idea, why does it spiral when it comes in? Why doesn't it just go straight in? That's because of the Coriolis effect. The Coriolis effect is a deflection, or turning, of wind and ocean currents caused by the Earth rotating out from underneath them. And I want you to watch this video, just a little clip from this video first, so you can really see kind of what it looks like, this Coriolis effect.
Now what if we were to have two people sit on opposite sides of the merry-go-round and try to throw a ball to one another? You can see that as the ball leaves the hands of the person throwing it, it becomes independent of the rotation of the merry-go-round, and therefore follows a straight path. But because the person trying to catch the ball is still rotating with the merry-go-round, they are quickly moved out of the ball's intended path. Because the merry-go-round is spinning counterclockwise, this deflection is to the right. If it were spinning clockwise, the deflection would be to the left. Now, to an observer above the merry-go-round, the path of the ball appears straight. However, to people on the merry-go-round, the path of the ball curves to the right of the intended motion. This experiment demonstrates how the rotation of the merry-go-round appears to cause a deflection in the path of the ball. This also demonstrates how air movement on the Earth's surface can be deflected by the Earth's rotation, a phenomenon called the Coriolis Effect. How do we relate the effects of the Coriolis force to air motion in our atmosphere?
Okay, so that basically showed how a ball in that case, but how the wind gets apparently turned to the right. So, but if you were above the Earth and you look down and you could see the wind, you would see it going straight, or it would look like it'd go straight. But on the Earth's surface, it appears to make this turn to the right. And this little picture kind of shows the same idea that, let's say you're firing a missile from somewhere near the North Pole, and you want to fire it to where the target is here. Okay? You shoot the missile. It takes some time to get down here towards the equator, but the Earth is spinning. Okay? At the equator, the Earth is spinning about 1,000 miles per hour. It's around 1,018 miles per hour. So if you just aim for this spot, by the time the missile gets there, the Earth has actually turned and you're going to hit somewhere else. All right, you hit the continent here. Okay, so you'd have to aim ahead of your target and let the Earth kind of, go to meet it. Okay, so that's what also happens with wind. If we would have wind that would be going from north to south, let's say, it would also be deflected. It's going to turn to the right in the northern hemisphere. But if you're in the southern hemisphere, it'd be turning to the left. And I can show you that in class a little bit better. Okay? And that's what causes that air to spiral to make the hurricane. So as the air goes into the center of where the air was rising, it can't just go in straight. It has to turn, so to the right in the northern hemisphere and to the left in the southern hemisphere, which is going to make it go counterclockwise for the hurricanes and clockwise in the southern. Okay, let's go on to the parts of a hurricane right away. And if you look at the back of your note sheet, I put a diagram that you can label. Okay, so there's not too many parts to a hurricane. In the center of the hurricane is the eye. Okay. Again, if you look at your sheet, what is the air doing in the eye of a hurricane? Okay. It is going down. It's going straight down, so it's falling straight down. That's why it's really calm in the eye of a hurricane, and why there aren't any clouds in it. You only get clouds when air rises, because it gets cooler in the atmosphere and the air can't hold the water, so it condenses out to make clouds. Okay, whenever air falls, it gets warmer, okay? So there aren't going to be any clouds. Okay, so the air is falling, it's clear, it actually is pretty cold. Okay, it gets a lot colder because you're taking air from really, really, really high up. Okay, just outside of the eye, these really dense clouds, that's the eye wall. Okay, what's the air doing in the eye wall? As you can see from your sheet, it's spiraling upwards. Okay, so the air in the eye wall is spiraling upwards. That is the worst part of the hurricane. Then on the very outskirts of the hurricane, you can see in the pictures here, okay, those are the spiral bands. Okay, they're just made of strong cumulonimbus clouds that are radiating out from the center of the hurricane. And you can watch these little short videos about what it is when you go into the eye. We can also watch some videos in class about going into the eye of a hurricane. It's pretty impressive, especially when you fly an airplane through the eye wall and then you emerge into the eye. It's pretty cool. Okay, size of hurricanes. They're huge, obviously, but they really do come in a variety of sizes. Look at this one down here, Hurricane Andrew. Okay, a lot smaller than maybe this one, Hurricane Floyd. Both of these hurricanes were really, really strong. Hurricane Andrew has the highest winds ever recorded for a hurricane, 220 miles per hour. Hurricane Floyd, also a really huge one, but again, a lot bigger in size. Typhoon Tip, okay, farther across than the United States is tall. Okay, and here's another really big one here. So the eye, if you want to label kind of on your map again, or on the picture on the back of your sheet, the eye, about 20 to 40 miles wide, if you just want to label your picture. The spiral bands extend outward maybe 200 to 500 miles, but again, they could be larger, as you see in Typhoon Tip here. And the height of a tropical cyclone is about 9 miles tall. Okay. Hurricane season. When is hurricane season? Well, hurricane season officially is from June 1st to November 30th. Okay? And it says, as seen in the graph to the right, the peak of the season is kind of August to late October, but they can occur at any time during the hurricane season. Okay? Mainly, though, you see they're kind of August through October is the highest number of hurricanes. Okay? But you do occasionally get them year round. Okay. A tropical cyclone doesn't just start off as a hurricane or typhoon. Okay? It starts off weak as a tropical depression. Okay, so the first stage is a tropical depression. It's just a low pressure center with the winds less than 38 miles per hour. Okay, so it's basically spiraling winds less than 38 miles per hour. If it intensifies, so it gets between 39 to 73 miles per hour, it becomes a tropical storm. And I put another little blank on your note sheet there because we do something when it becomes a tropical storm. We give it a name. Okay, so you put that we name it when it becomes a tropical storm. Then if it intensifies even more, so 74 miles per up and higher, it becomes a hurricane or cyclone or typhoon. Okay? Now again, what's the difference between those three? Just location. They're all tropical cyclones, which is why I kind of, use the names interchangeably. Tropical cyclone is just the general name. Hurricanes are the ones that are mainly Atlantic Ocean or ones that are in the Pacific that affect the United States. Cyclones mainly in the Indian Ocean, okay, but sometimes Australia will call them cyclones also. And then typhoons are mainly in the Pacific Ocean. Okay, so same thing, they're all the same idea. It's just different names for different locations. Before I go to that, are they all the same strength? No, usually typhoons are a little bit stronger, or on average, I guess I should say, typhoons are a little bit stronger. And that's just because they have a bigger ocean to intensify at. So when we look at typhoons, that happen this year or last year, we'll see that there are a lot more category 4s and 5s than hurricanes. Okay, a lot worse storms because they have more time to intensify. This is a kind of a neat picture. It shows the tracks of tropical cyclones from 1851 to 2005. Basically, you see, kind of as we saw, they start near Africa, they go over, and they recurve. Okay, I can draw that on here. Okay, so they're going this direction, and then they tend to recurve like that. Okay, notice that a couple have actually made it all the way up to England. Up here, there was one called the Labor Day Hurricane that actually was on Labor Day, obviously, but actually destroyed stuff on the coast of the U.S. and made it all the way back up and destroyed stuff in England. Same kind of thing here. They go and they start to recurve. Same thing happens in the Pacific. They go to the west, then they recurve. Same thing happens here. They recurve. Same thing happens here. They recurve. Okay. So why do they go to the west and then they start to recurve back to the east? Okay. The reason for that is something we haven't learned yet, but it's about the global wind patterns. Okay. Down by the equator, that's the trade winds, and the winds basically go east to west. Okay. Where we live in the westerlies. Our winds, our storms, everything go pretty much west to east. Okay, like that. So what happens is these hurricanes, if they get a little bit farther north, they're in the trade winds, they get a little bit farther north, they get up and up, now they have to recurve because they're in the westerlies. Okay, and we're going to talk about this quite a bit when we talk about climate and weather later in the year, about why they recurve. Okay, next thing is hurricane naming. I think we'll do that on part 2 because the time is about up for this one.